Good morning, everyone, and thank you for attending the webinar. As you all know, there is enormous interest in FDA's preventive control rules for human food. This was previously known as hazard analysis and risk-based preventive controls. This has created enormous interest both in the domestic area as well as in the international area, actually. The subject matter is too much to explain in 1 hour, so I'm just going to try to provide a bird's eye view of the whole thing because it's extremely difficult to cover everything in 1 hour. So if you are interested in knowing the full details of the PC rules, that is preventive control rules for human food, I request you to attend one of our upcoming training sessions. And this is going to be under FSPCA, which is otherwise known as Food Safety Preventive Control Alliance. We are going to conduct training sessions almost every month, so you may attend one of those training sessions, actually. Okay. The current good manufacturing practice, hazard analysis, and risk-based preventive controls for human food regulation. And previously this was known as HACCP, and now this is called PC Rules for Human Food, was published sometime in September 2015 to ensure safe manufacturing or processing, packing, and holding of food products for human consumption in the United States. Basically, it's a proactive and systematic approach to food safety, focusing primarily on preventive controls to prevent food safety issues rather than reacting to problems as they arise. These preventive controls work synergistically with other relevant programs such as GMP, Good Manufacturing Practices, Good Agricultural Practices, GAP, and also Good Transportation Distribution Practices, sometimes known as GDP. Successful application of preventive controls not only helps to meet regulatory compliance, because this is a regulatory compliance, but also minimizes the risk of producing products that can harm consumers. Well, I'm the Technical Program Director, Perry Johnson, Registrar Food Safety, located in Troy, Michigan, a company specializing in food safety certification of food processing and other sectors in the food supply chain to a variety of GFSI and other related standards. The objectives of this webinar are twofold. First, to give you a quick overview of the basic provisions of the Food Safety Modernization Act, which you may be aware of, FSMA, and also to help you understand the requirements of preventive control rules for human food so that you can implement the requirements in your areas of operation. This section, Part A, I will explain the basic provisions of Food Safety Modernization Act. Before we actually proceed any further, we should find out if the preventive control rules are applicable to you. FSMA is not applicable, as some of you may know, FSMA is not applicable to genetically engineered crops. And the Food Safety Modernization Act required FDA, the United States Food and Drug Administration, to establish new regulations for, number one, standards for produce production, which is primarily known as produce rule, and also food safety measures for facilities that process food for human consumption, and this is currently known as preventive control rules for human food. And it's not the subject of this webinar to discuss the details of produce rule. I'm going to focus primarily on the second one. And in the next slide, I'm going to make use of a flowchart from the National Sustainable Agriculture Coalition, dated November 2014, to explain the applicability of the preventive control rule for human food. Let me go to the next slide. This is known as PC Rules Decision Tree. The first question is, do you only manufacture juice, seafood, or dietary supplements, alcohol, or low-acid canned food? If your response is positive, then the PC rules for human food, they are not quite applied to you. Okay. On the other hand, if your response is no, then you ask the second question. Do you only hold, that means storing products, raw agricultural commodities other than fruits and vegetables that are destined for further processing? Again, if your response is positive, the preventive control rules are not quite applicable to you. Then if the response is a no, then the third question is, do you only hold or store packaged foods that are not exposed to the environment and does not need any refrigeration, that is ambient storage? If it is yes, then preventive control rule is not quite applicable to you. On the other hand, if your response was no, ask a question. Do you really sell products, food products, for less than 1 million per year? And this 1 million should come from the average of last 3 years. Or do you have less than 500 employees? If it is yes, then go here. The question is all human food you manufacture, process, or pack, or hold, is it a low-risk product? And is it done on the farm? And if your if your response is yes, then you go to the next, you go to this box, and if your response is some are done off farm, then the PC rule is applicable, but as a qualified facility. Let me just go back to this question. Do you sell less than 1 million per year, or do you have less than 500 employees? And if your response was no, then you have two options. Then ask a question, is your income greater than 1 million per year and you have more than 500 employees in your organization? Then the PC rule, the preventive control rule, is definitely applicable to you. On the other hand, if it is greater than 1 million per year and you have less than 500 employees, then still the rule is applicable, but that is under small business category. So this is going to be quite useful to you to decide whether the PC rules, I'm going to just say PC rules throughout my presentation. The PC rule is definitely applicable to you or not. You can find out from the decision tree. Okay, I'm moving on to the next part, which is part B. In this section, I will introduce you to the preventive control rules for human food. You're all quite familiar with HACCP. It's a global food safety standard developed in the early 50s primarily for the space program and also to harmonize international food safety standards, guidelines, and codes of practice, primarily to protect public health, actually. So again, I'm sure you're too familiar with the 7 principles of HACCP, which is identify potential hazards, determine critical control points, assign limits to CCPs, monitor the limits, take appropriate corrective actions when the CCPs are deviated, and verify the effectiveness of the HACCP plan and maintain records. You're too familiar with all the 7 steps. I don't have to spend too much time on this. Whereas the next slide, it's again the PC rules for human food. What are the basic steps? You have the same 7 principles or 7 steps here. The US FDA created preventive control rules within section 103 of FSMA to help the food manufacturing and processing facilities implement a comprehensive and proactive system to ensure food safety. PC rules for human food is a US standard. It's primarily a US standard that affects a number of FDA-regulated products and also facilities exporting products to the United States. And needless to say, it affects the domestic food product manufacturers, processors, packers, storehouses, and distributors. Whereas HACCP is a global standard. Okay. HACCP generally applies to low-acid, canned food, juice, and seafood processes. Whereas PC rules for human food, they're applied to almost all food processing facilities. The only facilities not required to comply with PC rules for human food are those subject to standards of produce safety, which I think I mentioned in my previous slide, or those governed by or those regulated by HACCP, such as seafood HACCP, and those facilities regulated by GMP for dietary supplement. Again, dietary supplement does not come under the preventive control rules. And small and very small business entities, as defined by the FDA, are also exempt from PC rules. Unlike HACCP, PC rules for human food also requires planning for potential terrorist acts and food fraud. Now let's see what PC rules consist of. I'm just going to expand the contents of the previous slides here, actually. First, hazard analysis. Hazard analysis is in PC rules is similar to the hazard analysis of the HACCP model, actually, HACCP model. But the scope is expanded to include identification and evaluation of known biological, chemical, physical, radiological, now radiological is also included in the chemical, and hazards that may be intentionally produced for purpose of economic gain. That's economic fraud, okay? The identified hazards must be assessed for risks and justification to be included in the preventive control program with appropriate justification. We are going to see these things in detail in the next few slides, actually. So then what about preventive controls? The preventive controls required by FDA are, number 1, process control, 2, allergen control, 3, sanitation control, and 4, supply chain control. There may be other controls which you need to identify for your product. FDA is of the view that not all preventive controls are process controls. HACCP is primarily focusing on process controls, whereas FDA is of the view that not all preventive controls are process control. This is a major shift in approach. Supplier control by companies is also important because there may be a few hazards coming through that area, supplier control. And in fact, acceptance of supplier's certificate of analysis, normally we call it COA, or copies of second and third party audit may or may not be quite sufficient to meet the FDA requirement in the future. Okay. Now, the preventive control rules also talk about what is known as parameters. What is this? This is similar to critical limits in HACCP. the parameter controls must either be defined with or without limits. You can have parameters with or without limits, without numbers assigned to these things, depending on whether these are measurable. All steps involved, or rather all steps identified as preventive controls, need to have assigned parameters. Now, monitoring is something similar to what you are familiar with in the case of HACCP. PC rules have not, the preventive control rules have not defined any frequency. It's up to you, it's up to the facility to decide how often it's necessary in order to safeguard their product from possible contamination. Now, corrective action is also going to be somewhat similar to what you are familiar with. Corrective action procedures are required for all foreseeable problems. There's a slight difference. Now, what is a foreseeable problem? Everything is defined in CFR 117.3, which covers the definitions, actually. Okay? Document evidence is required that identifies how corrective actions address preventive controls. In fact, root cause analysis must be done before corrective action. Without doing root cause analysis, you cannot implement an effective corrective action. Further, a qualified person must be consulted in the case of unforeseeable events to ensure safe course of action is followed when the need for corrective action arises, actually. Now, verification. This is also similar to what you have seen in the case of HACCP, but the difference is a qualified individual must verify that the preventive control programs and the frequency of monitoring as defined in the food safety plan are performed as documented. The frequency of verification must be weekly. I think this is what the rule defines. To ensure compliance to the PC rules, it cannot be just once a month, once a quarter. No, I think these things need to be verified by the qualified individual within 7 days. Record keeping, similar, but the records must be kept on site for a period of at least 2 years, or it should be easily accessible. Recall program is again a part of the food safety plan under preventive control rule. An effective recall program to recall defective products, and the two in a timely manner, is a critical component of the preventive control rules, actually. Calibration, again, is gaining importance here because accurate measurements of parameters is critical to PC rules. And all instruments must be checked and validated for calibration purposes with documented procedures. And all these things need to be kept on file for review. Now let's see, I think this is a schematic that I have taken from the FSPCA, which is Food Safety Preventive Control Alliance Instructor Guide 2015. This is, in fact, the food safety plan I'm talking about is a dynamic document. And this plan must be kept current when changes are made to the system. What is current, actually? When changes are made to the system, or when you make some changes to equipment, or when you add new products, etc., or even when new hazards are identified, you need to revisit the food safety plan. Okay? The food safety plan obviously starts with hazard analysis to identify the required preventive controls, not only for the process. Of course, for process, you need to identify the hazards, and also for sanitation, food allergens, and supply chain program, as we saw in the previous slide. Okay? These are, in fact, needed to address the hazards requiring a preventive control. Okay? These elements, hazard analysis, recall plan, process control, supply chain allergen control, etc. These things form these are the components of the food safety plan. And GMPs and other prerequisite programs here, they are managed outside of the food safety plan. Okay? These are, of course, these are essential, these are definitely required, but these are managed outside the food safety plan. Probably, I think many people are managing through standard operating procedures, documents, and records, actually. So these are the components of a food safety plan under the preventive control rules. Let's examine further the contents of the food safety plan. First, I'm going to focus on the requirements of a food safety plan as required by CFR Part 117.126. Okay. As per PC rules, the owner or the operator or agent in charge of the facility or a facility prepare and implement a written food safety plan. The term written food safety plan is related to food safety rather than to other plans, such as, you may have quality control plans, a food defense plan, all written. But the description written food safety plan should not be confused with written or documented quality control plans and food defense plans. And the written plan is essential for the facility to implement the plan in a consistent manner. Also, it can be used as a training material, okay? And it can also be used to periodically reanalyze and update the plan, okay? Now, what about the contents of a food safety plan? This is addressed in Part 117.127, okay? And as per this section, this requirement, the contents of a food safety plan should include, number one, written hazard analysis, number two, written preventive controls, three, written procedures and the frequency with which they are to be performed for monitoring the implementation of preventive controls, four, the written corrective action procedures, five, the written verification procedures, and finally, the written recall plan. So, what is required by the preventive control rule under Part 117.127 is you must have written documents like this: hazard analysis, preventive control, the procedures and the frequency, corrective action procedure, verification procedure, written recall plan. And the third bullet point here is about preparation of food safety plan by a qualified individual. Okay. The PC rules actually require that the food safety plan be prepared, or at least if somebody else is going to prepare, it must be overseen by a preventive control qualified individual. Actually, the acronym is PCQI. A PCQI, preventive control qualified individual, must develop the food safety plan in order to ensure the preventive control rules are the preventive controls are effective, not the rules. Rules are effective, of course, but the preventive controls developed by the facility are effective. And the plan must actually be designed to identify and significantly minimize or prevent hazards in order to prevent illness or injury, actually. It requires some knowledge of hazards associated with product, process, and what preventive controls can be used, etc., etc. It definitely requires a lot of technical knowledge. And FSPC, again, Food Safety Preventive Control Alliance, has developed a course, and this course is one way to meet the requirements for a preventive control qualified individual, actually. Under the regulation, actually, the preventive control qualified individual is supposed to perform or oversee 4 different things. One, the PCQI must either perform or oversee preparation of the food safety plan. That's number one. Number two, validation of the preventive controls. That is also the responsibility of the PCQI. Third, records review, reviewing records. Four, reanalysis of the food safety plan. So these are the primary four important responsibilities of a preventive control qualified individual. And in fact, there is a definition of PCQI under 117.3, which is a qualified individual who has successfully completed training in the development and application of risk-based preventive controls, at least equivalent to that received under a standardized curriculum recognized as adequate by FDA, or is otherwise qualified through job experience to develop and apply a food safety system. So the preventive control, there are two qualification routes. One, to take an FSPCA kind of developed course or training program, or qualified through job experience. Both are possible. So part C, we are moving to part C. Here I will discuss the requirements of PC rules in detail. The first one talks about hazard identification in PC rules. Again, many of you are familiar with all the hazards, but I'm just going to give some additional information on that. Biological hazards, chemical hazards, physical hazards, economically motivated hazards. Okay. And though these things are not quite new to you, actually, I would like to just give some additional information, as I said. Under preventive control rules, facilities are required to identify the food safety hazards requiring preventive controls. This depends on the food. Of course, it depends on a number of factors. It depends on the food you are considering to manufacture, store, or pack, the ingredients that go into making the product, the equipment, the facility layout, and other elements of the facility's food safety system. Okay? Once the hazards requiring a preventive controls are known, I think you need to identify those hazards that require preventive control. Okay? Biological hazards include microbiological hazards such as parasites, pathogens, and other microorganisms of public health significance. Chemical hazards include substances such as pesticide residues, drug residues, natural toxins, unapproved food or color additives, food allergens, and radionuclides, and things like that. Physical hazards, again, you people are quite familiar with that, you know, bits of plastic, pieces of plastic, and things like that, or metal fragments. And economically motivated hazards. Again, just to give you some examples of parasites, Cryptosporidium is an example of parasite. Again, you're quite familiar with a number of other microorganisms such as Campylobacter, Clostridium, E. coli, that is 0157, etc., etc. So you're quite familiar. I mean, we cannot get into all these details in 1 hour. Actually. Talking about chemical hazards, okay, again, these things include pesticide residues, natural toxins, etc., etc. Natural toxins such as aflatoxin, patulin, these are well-recognized, well-known examples, which occur in materials such as peanuts, apple juice products, etc. Patulin occurs in apple juice products in general. Okay? You may also like to consider decomposition products such as histamine. This is produced from amino acid histidine, when certain bacteria grow, and definitely this is going to pose health risk. Okay. Again, undeclared food allergen. Again, you are quite familiar with all these things. Can cause life-threatening reaction actually in susceptible individuals. Heavy metals. Again, that can lead to impaired cognitive development in children. Okay. Radiological hazards, this is quite new to you, and I'm not saying this is very common, but it may occur, it can occur actually. Okay. This includes things like radium-226, radium-228, strontium-90, iodine-131, and things like that. Okay. In fact, food may be subject to contamination with these hazards. Example, if water used to manufacture a food contains a radionuclide. There are reports that some well water sources, they are contaminated with radionuclides. That is why FDA has come up with this kind of hazard. Now, what about economically motivated hazards? Okay. Hazards may be introduced into food for a purpose of economic gain sometimes. Some people intentionally do that. But economically motivated adulteration that affects only product integrity or quality and not food safety, that should not be addressed in the food safety plan as per FDA. Okay? The preventive control rules for human food requires only those things that will have an impact on food safety. I can give you an example. This is the melamine contamination in China. This was added to dairy products by some milk farms back in China to increase the protein content, and this resulted in more than about I think 300,000 infants falling sick, and in fact 6 deaths were reported actually. Okay. The other example is addition of dyes, colors containing lead, heavy metal actually, to ingredients such as spices. These are just 2 examples of adulterants that were intentionally added in the food trade. So, you will agree with me that doing a thorough, comprehensive hazard analysis is quite important. And I know that this is the most difficult thing to do, because you should have knowledge about the hazards present in materials, processes, and things like that. Okay? A systematic and thorough analysis of potential hazards and their consequences will definitely help to ensure that all hazards requiring a preventive control are appropriately identified and adequate control measures are in place to mitigate or eliminate these risks. I have just provided an example of a hazard analysis template or hazard analysis form here on this slide. And this I have taken from the Food Safety Preventive Control Alliance Instructor Manual. You describe, column 1, you describe the ingredient or process step. Identify, column 2 here, you identify the reasonably foreseeable hazard. And just describe the source or origin of the hazard and things like that. This is just an example of a template that you may be interested in using to meet the requirements of PC rules. Okay. So once you have identified the hazards, you need to evaluate the hazards. The next step is evaluate. How? Hazard, that this is, again, going back to the HACCP model, that is occurrence versus severity, actually. Okay. PC rules, in fact, PC rules require that the hazard analysis include an evaluation of the hazards identified to determine whether these hazards are reasonably likely to occur, including an assessment of the severity of the illness or injury, if the hazards were actually to occur. Again, the first thing is microbiological or biological hazards. Okay, I'm just going to give an example here. The severity of the illness or injury includes the magnitude and duration of the illness and impact of any chronic conditions that may result from the illness. Example, reactive arthritis following a salmonella infection. Reports are there stating that people got into food infection to salmonella, etc. They may develop reactive arthritis in the future. So all these things need to be considered, actually. In fact, contamination of food with biological hazards often lead to either immediate or near-term onset of illness or injury. Example, gastrointestinal illness. Obviously, it affects the intestinal tract. Or exposure to some biological hazards may also have long-term consequences, as I just mentioned. That is, infection with salmonella may result in reactive arthritis. These things need to be considered when you evaluate identify the hazards. Going back to chemical hazards, again, an allergic reaction is a typical example there, actually. Or residues in milk products, say for example, penicillin residues, antibiotic residues to treat cows. Mainly, I think these chemical hazards, the focus is on the long-term effects, such as impaired cognitive development in children exposed to lead in contaminated candy and sometimes even in water these days. Okay? The PC rule would require that such chemical hazards be considered to determine whether they are reasonably likely to occur, even if it occurs infrequently. So the PC rule definitely wants you to consider these things. What's going to be the effect, long-term, short-term, and things like that. Again, I can go on giving examples like that, aflatoxin and pathogens, but because there's no time, I'm going to skip some of these examples, actually. Okay? And physical hazards can also pose health risk. You're quite familiar with these things. Hard or sharp objects may lead to perforation of tissues of the mouth, tongue, throat, etc., etc. Okay. Again, there is a requirement to evaluate environmental pathogens. As a matter of fact, PC rules require that hazard analysis includes an evaluation of whether these pathogens, environmental pathogens, are reasonably likely to occur. Whenever an RTE, that is ready-to-eat food, is exposed to the environment prior to packaging. It's required when you make or manufacture ready-to-eat food that is exposed to the environment before packaging. Okay? You also need to consider specific factors in hazard evaluation, actually. Okay? Maybe it is related to product formulation, because the preventive rules definitely requires you to do hazard evaluation while formulating the food. For instance, there could be some interaction of the individual ingredients that may become a source of hazard. So that needs to be addressed during the product formulation stage. Also, it requires you to consider design of the facility and equipment, what hazards can arise from the design of the facility, and what hazards can come through raw materials, and what about manufacturing, processing, etc., etc., even storage and distribution. So it requires a thorough analysis of hazards coming from several sources so that you can come up with proper preventive control rules. So that is the objective of doing a comprehensive or thorough hazard identification and hazard evaluation, actually. Okay, I'm going to give an example of a hazard evaluation form. For instance, the first column, this is receiving of liquid pasteurized egg, for instance. Okay, and then what are the potential food safety hazards? Obviously, salmonella. It contains salmonella. Okay, but it may contain vegetative pathogens such as salmonella. Okay, and the next question is, does this hazard require a preventive control? Because you remember I was telling you that we need to identify hazards so that we can come up with appropriate preventive controls. So here is the question, okay? Does it actually require a preventive control? The answer is yes. And then you need to justify what you have stated in column 3. And this is just an example, okay? While pasteurization minimizes the likelihood of salmonella, USDA recommends the product be used in cooked foods. Okay? Experience has shown salmonella occasionally occurs in this ingredient, and that's the reason why you have come up with, or why you are going to come up with preventive controls. Similarly, allergen, because egg is an allergen. So, and that must be labeled to inform consumers, actually, because some consumers are sensitive to egg proteins. Okay, so that's why you have to come up with appropriate preventive control measures. That is in column 5, and you are saying here, yes, this requires preventive control. So what is the definition of preventive control? And again, the definitions I just mentioned to you earlier, the definitions are mentioned in CFR 117.3, which states those risk-based, reasonably appropriate procedures, practices that a person knowledgeable about the safe manufacturing, processing, packing, or holding of food products would employ to significantly minimize or prevent the hazards identified under the hazard analysis that are consistent with the current scientific understanding of safe food manufacturing, processing, packaging. Sorry, I think it is too long, but this is what FDA has defined as preventive control. Let me move on to the next slide. What are the various preventive controls that PC rules are talking about? Number 1, you have process preventive controls. 2, allergen preventive controls. 3, sanitation preventive controls. Supply chain program, recall plan, other preventive controls. And these preventive controls, and what are they basically? Depending on the hazards you have identified earlier, preventive controls may include just maybe one or many of these preventive controls, or some of these preventive controls. Preventive controls identified at specific processing steps are process preventive controls, such as critical control points. In general, process preventive controls are equivalent to your critical control points in your HACCP plan. Allergen preventive controls include the essential allergen management procedures identified in hazard analysis. Assuming that you have identified allergen as one of the hazards, the preventive control is allergen preventive control. Similarly, sanitation, and similarly, supply chain. For Talking about supply chain program preventive controls may be necessary when a manufacturer relies on the supplier to control hazards requiring a preventive control there. Okay, say for instance of a particular ingredient, and that too because the receiving facility does not, that is, the facility does not have a step to control the hazard. Okay? In fact, the recall plan is, in many cases, it's not used to manage hazards requiring a preventive control. But the fact is, it can reduce the number of illness if a contaminated product is recalled quickly, and that's why this is included in the preventive control. The reason is, I think, if you have an effective recall plan, you will be able to recall the product quickly so that you can avoid further adverse effects in the marketplace, actually. Okay. There may be other preventive controls. Remember, it's not just 4 or 5 preventive controls you have in the system. There may be other preventive controls, such as hygiene training in sensitive area. That can also be a preventive control. It depends on the type of product you make and the type of hazards you encounter and things like that. I will provide some examples of the preventive controls. First, let me take the biological hazard. Okay. The common control measure here, preventive control measure, is kill step. Okay. Maybe different types of thermal processing, irradiation, high pressure processing, etc., etc. This is just an example of preventive control for biological hazards. Then you're quite familiar with that, actually, you know, your pasteurization, time temperature combination. This is just an example of biological hazard preventive control. You assign values, you assign numbers, and you call it CCP or you call it preventive control under the PC rules for human food. An example of preventive control, chemical I'm talking about, is testing and rejection of ingredients that may contain excess concentration of, say, certain natural or artificial chemical hazards. Allergen labeling is another example of allergen preventive control. Okay. Similarly, we can come up with allergen labeling, supply chain program testing I just mentioned to you. Okay. This is an example of preventive control for physical hazards, you know, process control such as filtering, metal detection, X-ray devices, and things like that. So, what factors would you consider in selecting preventive controls? Okay. In fact, the food safety team must consider many factors when identifying preventive controls for the food safety hazards requiring them. And selection of these controls should also include assessments with regard to, number one, its effect on food safety hazard. Then, its feasibility for monitoring. Can you actually monitor the control? 3, does it have an effect on other preventive controls? So these are some of the factors that you need to consider while identifying preventive controls for the hazards, actually. Okay? I'm just going to give some examples of the templates. Again, all these templates have been taken from the Food Safety Preventive Control Alliance training program. And here, this is an example of process preventive control. Okay, I'm focusing on column 5, process control, cooking. Cooking is the preventive control here with a proper time temperature combination. And in the next slide, I have given an example of allergen preventive control. Okay. Allergen control. You review the labels for allergen information. You make sure that your sanitation, your cleaning program is effective. Otherwise, it's going to lead to cross-contamination and things like that. So that's how you come up with a preventive control plan for allergens. The third one is sanitation here, okay? No, in fact, here, there may be a possibility of introducing pathogens such as listeria, actually, from the environment. And then you come up with proper sanitation controls to prevent recontamination. And the last one here is an example of supply chain preventive control. For example, just going back to receiving refrigerated ingredient, actually. Okay. What is a hazard? Here there is a biological hazard, salmonella and E. coli and things like that. Okay. And how do you do that? This is through supplier control. Third-party supplier audit by a qualified auditor. That's how you mitigate that hazard or risk. Okay. Now, I just made a mention about parameters and values in the PC rules. What are those things actually? Okay. The parameters are those factors that must be controlled to ensure the hazard will significantly minimize or prevent the risk. Okay. For most process-related preventive controls, measurable parameters can be identified. I just gave the example of cooking, cooking temperature, time. And in fact, this can also be treated as your CCP in some cases, actually. Therefore, the critical limit must be met at the process control to significantly minimize or prevent the hazard from occurring. Okay. I think there are several examples of parameters such as, flow rate, line speed, weight, viscosity, moisture level, etc., etc. It depends on the type of process you are using. Okay. And here, the preventive control rule aligns very well with HACCP because I think this is meeting the requirements of HACCP. So it aligns very well with the HACCP model. And, sorry about that. Then what about monitoring, actually? Monitoring, again, this is something somewhat similar to the HACCP model. Requirement for written procedures for monitoring. I think there is a requirement for documented procedures for monitoring. And again, monitoring is defined in CFR 117.3, which is to conduct a planned sequence of observations or measurements to assess whether control measures are operated as intended. This is a definition of monitoring as per 117.3. PC rules actually require that the monitoring procedures include the frequency with which they are to be performed. The frequency of monitoring must be sufficient. They don't tell you the actual frequency, but they want you to come up with a frequency sufficient to ensure that the preventive control or controls are consistently performed in order to ensure that the preventive controls are effective. Basically, it is your responsibility to come up with a frequency that is adequate to control the hazard, meaning to make sure that the preventive controls you have identified are working effectively. And this is about record keeping. Record keeping is similar to the HACCP model. PC rules actually require that all monitoring of preventive controls be documented in records that are subject to verification, because these records are going to be verified by a number of people. For instance, the preventive control qualified individual to begin with. It may be verified by FDA and things like that. So primarily this is to make sure that the preventive controls are, number one, adequate, and also to make sure that these things are working effectively so that you can minimize or prevent these hazards. And what records are to be kept? That's another question we have. Number one, you have to have written food safety plan. Okay, you may call it a document, you may call it a record, but FDA wants you to have written food safety plan, including written hazard analysis, preventive controls, monitoring procedures, corrective action procedures, verification procedures. I showed you some templates in the previous slides. These are some of the things you must keep to meet the requirements, PC rules requirements. Okay. Records that document the monitoring of preventive controls. This is another record that you are supposed to keep. Records that document corrective actions. Records that provide evidence that verification is taking place. And also training records for the qualified individual. So these are some of the records that you are required to keep mandatorily. What about corrective action? Because this is one of the steps in the 7 principles of HACCP, right? So corrective action. Now, facilities must establish procedures to ensure that if preventive controls are not properly implemented, or if these controls are found to be effective, then you need to have a corrective action plan. Okay. This will also ensure that you are taking appropriate action to reduce the likelihood of reoccurrence of the implementation failure. Why you take corrective action? To make sure that such a thing is not going to happen in the future. Okay. So you are supposed to have a written corrective action procedure, and you're also supposed to anticipate, rather I think you need to have corrective action procedures for unanticipated problems. In fact, a facility might not anticipate all of the problems. You may not be able to anticipate all problems, but your corrective action procedure should cover, the scope should address even unanticipated problems. Okay? For instance, detecting a pathogen in a ready-to-eat food may signal that preventive controls for that pathogen, say for example salmonella or listeria, are not effective. And so this is totally unforeseen. This would have been totally unforeseen. So you are supposed to have corrective action procedures for such eventualities also. And when we talk about documentation, the rule requires that all corrective actions taken to address these things be documented in records that may be verified, that is subject to verification at a later date. Okay. Now, a quick thing about verification in PC rules. We need to talk about verification and validation. I know it's almost time, but I'll take only another 5 minutes to just complete. Under the preventive control rules, the owner or operator or agent in charge of a facility must verify, number one, the preventive controls implemented are adequate to control the hazards identified, and you are conducting monitoring appropriately, and you are making decisions about proper decisions about corrective action, etc., etc. And again, many of you are quite familiar with validation. So validation, again, facilities are required to validate the preventive controls because they need to be effective. In order to make them effective, you need to validate, actually. Okay. And again, the PC rule requires that the validation of the preventive controls be performed by a PC qualified individual. I just mentioned to you in the first few slides that this is one of the responsibilities of a PC qualified individual. Okay. In some cases, validation may not be required under preventive control rules. What are those things actually? Allergen control. FDA has stated clearly for allergen control you need not validate the preventive controls actually. Similarly for sanitation controls, for recall plan, for all these things you don't have to validate, but you need to validate, say for instance, process control, preventive controls. You must validate those things actually. Okay. And I told you in one of the earlier slides that calibration is also taking a big role here actually. Okay. The rules require calibration of process monitoring instruments and verification instruments be calibrated because they're looking for accuracy of all these monitoring equipment. Again, product testing is another important area. The rule emphasizes the importance of environmental and product testing program in preventive controls. Okay. It doesn't indicate under what specific circumstances product testing would be required, but FDA is of the view that the role and need for these test measures may vary depending on the type of product and activities of a facility. It may be unique to your facility. So you need to identify those things and then take care of testing, etc. On this slide and the next slide, I have just made a quick comparison of the GFSI, that is Global Food Safety Initiative, food sector categories, and I have just indicated whether FSMA is applicable, whether PC rule is applicable. Say, for instance, fish farming, okay, which is farming one fish. Under GFSI, FSMA is applicable, but under PC rules, it's not applicable because it's covered by seafood HACCP. Similarly, fish and fish product processing. And this is the next slide. What about thermally processed low acid food? Okay, is this applicable? Is it things like that? So thank you very much for listening to me. And I know it's subject matter is too vast and it takes a lot of time. I strongly suggest that you undergo any one of these FSPCA training sessions to get familiar with the requirements. Thank you very much for your attendance. Thanks a lot. Any questions, please? Okay, there were a few questions. Will presentation be available after the webinar? Of course, presentation will be available on our website. We'll make it available, actually. Okay. The other question was, yeah, okay, finally got it. What do you mean by PC? PC is preventive control rules, because rather than repeating it several times, and I just wanted to call it PC, actually. So, yeah. And the third question was, from everything I'm hearing, a combination of a BRC food safety plan, a HACCP plan, and a food defense plan would meet the FSMA requirements for food manufacturing. Is this correct? Yeah, I think you're almost there, but that's what some of these GFSI standards have done, actually. They have compared, say, for instance, SKO for FSSC or BRC, they have compared their requirements against the PC rules, and I'm not going to say it is 100% match, but it's almost there, or in some cases they have exceeded the PC rule requirements. Thank you. Yep. Yeah, the other question is, as a Canadian food manufacturer exporting to US, do we need to start any action from our side? We are GFSI certified plant. Of course, if you are exporting to the United States, if a product is coming into the country, you must comply with the requirements of PC rules. If there are no more questions, then thank you very much. Thanks a lot.